Hello, my name is Taylor. I'm a biology major from the class of 2019.
Hello, my name is Connor and I'm an animal science major from the class of 2018. And today we'll be working on problem 2 from chapter 7.4 in the general chemistry workbook.
The question states, which of the following represents isomers and which of the following represents resonance structures? And we are given 3 pairs of molecules to look at.
Before we begin, let's define what an isomer and resonance structure are. An isomer is a molecule in which 2 or more compounds have the same chemical formula but have different arrangement of atoms in the molecule and different chemical properties.
A resonance structure are 2 forms of a molecule where the chemical connectivity is the same, but the electrons are distributed differently around the structure.
So first, let's start by looking at set A. Set A would be considered isomers because the connections between the 2 molecules are different. The bromines in the first structure are on the same side of the molecule, whereas on the second, they are on opposing sides. Because of this, they have different connections and thus different chemical properties.
Now let's move on to set B. When comparing these molecules, you may first think that they are isomers because of the change in position of the bromine and the hydrogen. In reality, however, this is not a 2-dimensional molecule, and we know that this molecule is just rotating around the single carbon-carbon bond. Because of this, these compounds are actually identical, and thus neither resonance nor isomers. To help you visualize this, build a 3D model of it and prove to yourself that they are actually the same.
So lastly, let's look at set C. Set C would be considered resonance structures due to the movement of electrons between the 2 oxygens. Electrons in the molecule are able to travel between the 2 oxygens in the form of a lone pair creating a double bond between the oxygen and carbon. Also, electrons in the double bond can become a lone pair on one of the oxygens. This is considered movement of electrons within a molecule. It is important to note here that there is no gain nor loss of electrons, nor breaking and reforming of bonds in this molecule.